Okay, so looking at proficiency target 6. Now, before we dive into this, let's talk about what we have discussed so far. We've talked about how we can go from moles of something to items of something, of that same thing, okay? Like moles of carbon to atoms of carbon. And in order to do that, we used Avogadro's number, 6.02 times 10 to the 23rd. And then in the unit before this, we discussed how we could go from, or sorry, not the unit, the proficiency target before this. We went from moles of something to grams of the same thing. So like moles of carbon to grams of carbon, and that's the molar mass, or the periodic table, those numbers on the periodic table. And we can go back and forth between those items. Now, the new thing for proficiency target 6 is we can communicate between moles of something. And then what's cool is now we can look at moles of something new. That it does not have to be the same thing on both sides when it's moles to moles. That's when they can be different. And it can go back and forth. And what we use here is the coefficients in the balanced equation. So let me give you an example of this. So looking at number 1, we have a balanced equation here, and it says how many moles of H2O are produced if 0.176 moles of O2. So I want you to start noticing that what we are ending with and what we are starting with are not the same thing. H2O is not the same thing as O2. So the only way we can go between different things is when it's moles to moles and they are different things. So upper left is what we're starting with, 0.176 moles of O2. And I'm going to take that unit and I'm going to place it diagonally down below, moles of O2. And I want to end with moles of H2O. Just like when we are training our brain with Avogadro's number in grams over moles, now we're training our brain with moles over moles. So if you see moles over moles, I want you to start thinking balanced equation. Because I'm looking at moles over moles and it is H2O, and look, the coefficient in front of H2O is 6. So it's going to be 6 moles of H2O, and then the coefficient in front of O2 is 5. So it's going to be 5 moles of O2. Then moles of O2 cancels, and I'm left with moles of H2O. Okay, let's plug this in our calculator. Open parentheses because it's the top of the fraction. 0.176 times by 6, close parentheses, divide by, open parentheses, 5. So we are going to end with 0.211 moles of H2O. So that's how we can go from one item to something completely different. Okay, so again, if I am starting with 4 moles of nitrogen monoxide, NO, and I want to know how many moles of NH3, then I'm noticing that these are not the same thing. And so it can only be mole to mole. So upper left, I have 4.5 moles of NO. I'm going to put moles of NO down below, and we're going to end with moles of NH3. So moles over moles, I'm thinking balanced equation. So I'm going to look at my balanced equation. So NH3, there's a 4 in front of it, so it's 4 moles. And then nitrogen monoxide, oh, it's also 4. So then I can reduce this down to 1:1, or I can leave it the way it is and plug it in my calculator. Moles of nitrogen monoxide cancels. we're left with moles of NH3. And if I plug this in, I'll see that I get 4.5 moles of NH3. Okay, so part C. How many grams of H2O if I have 1.9 moles of NH3? Okay, I want you to notice something. NH3 is different than H2O. They're not the same thing. And the only way we can communicate between different things is moles to moles. Okay, so I'm going to think through my path here. I have moles of NH3, and then I'm going to go moles of H2O so I can get to the new thing. But once I'm in moles of H2O, so moles of NH3, then I can go to moles of H2O. Then once I'm in moles of H2O, then I can go grams of H2O, because then it'll be the same item. So we're going to go moles of NH3 to moles of H2O, and then grams of H2O. So I want to point something out. If it's moles to moles, they will be different. They won't be the same thing. But if it's moles to grams, then it has to be of the same thing. This roadmap is going to tell me what my goalpost looks like. Anytime I have an arrow, that's a new transition line. And then these are my units in this order. Moles of NH3, moles of H2O, grams of H2O. I'm going to take the units like I've always been doing with our goalposts, and I'm going to place them diagonally down below. So I'm going to take moles of NH3 and moles of H2O. If we see moles over moles, that's balanced equation. So H2O and NH3. It's 6 moles of H2O for every 4 moles of NH3. 6 moles of H2O for every 4 moles of NH3. And then when we see grams over moles or moles over grams, we're thinking periodic table. So 2 hydrogens and 1 oxygen. And if we add all that together, we get 18.015 grams. I put that with the grams in 1 mole. So moles of NH3 cancels. Moles of H2O cancels. And we're going to be left with grams of H2O. Now I'm going to plug it in my calculator. Open parentheses, 1.9 times by 6 times by 18.015, close parentheses, and then divided by, open parentheses for the bottom, 4, and then just multiplied by 1 and close parentheses. So we are ending with 51.343 grams of H2O. Okay, there's one more version of this goalpost where instead of starting with moles, it starts with grams. So we go grams to moles to moles to grams. And let's see if we can find a good example of that one. Okay, we're going to do number 3 together, and then I bet you'll have enough info and enough practice to be able to do the rest of this. Number 3. How many moles of aluminum chloride are produced for 5 moles of aluminum hydroxide? So aluminum chloride and aluminum hydroxide are not the same thing. And so the only way we can communicate between them is moles to moles. So I'm starting with 5.5 moles of aluminum hydroxide. And I'm going to put that unit down below. And I'm going to go moles to moles of aluminum chloride. if we see moles over moles, we're thinking balanced equation. So it looks like, now notice how there's not a number in front of aluminum hydroxide? When there's not a number there, it's because there is one of them. So it's 1 mole of aluminum hydroxide. Oh, and look, it's going to be the same for the aluminum chloride. There's not a number there, so it's only going to be a 1. So moles of aluminum hydroxide cancel. And if we run this and we calculate this, we're going to just end with 5.5 moles of aluminum chloride. Okay, now one of these on part B is starting with grams. So if 25.3 grams of HCl reacts with excess aluminum hydroxide, how many moles of aluminum chloride? That's why it's important to underline. Identify where you're starting and ending, because that was extra information. That's not part of this. We have this many grams that we're starting with, and we want to end with moles of aluminum chloride. And notice how hydrochloric acid, HCl, and aluminum chloride, they are not the same thing. So the only way I can move from hydrochloric acid to aluminum chloride is if I go moles of HCl to moles of AlCl3. That's the only time I can go from one thing to something different, is when it's moles to moles. But I'm not starting with moles, I'm starting with grams. So I'm going to have to go grams of HCl to moles of HCl, because remember, when it's grams to moles, they have to be the same thing. But when it's moles to moles, that's when they're going to be of different items. Okay, so here's my units. I have grams of HCl, then I'm going to go moles of HCl, and then moles of aluminum chloride. I'm going to take those same units and I'm going to place them diagonally down below. So it's going to be grams of HCl and moles of HCl. So if I have 25.3 grams of HCl and then it's moles over grams, that's going to be periodic table. So 1 hydrogen and 1 chlorine. Okay, so chlorine and hydrogen, so 1.008 plus chlorine 35.45. So that's going to be 36.458 grams per mole. Moles over moles is the balanced equation. So I'm going to look up that balanced equation. There's 3 moles of hydrochloric acid for every 1 mole of aluminum chloride. Look, I wrote the wrong one. Moles of HCl. So that's what should have gone here, moles of HCl. So 3 moles of HCl for every 1 mole of AlCl3. So grams of hydrochloric acid cancels, moles of hydrochloric acid cancels. I'm left with moles of aluminum chloride. Okay, plugging it in. We're taking 25.3 times by 1 divided by 36.458 times by 3. And so I have 0.231 moles of aluminum chloride. Okay, here's our last type. 250 grams of water, and we want to know how many grams of HCl. So water and hydrochloric acid are not the same thing. So the only way I can go from moles of water, the only way I can go from water to hydrochloric acid is if it's moles to moles. That's the only time that I can go between different things. But I'm not starting with moles, I'm starting with grams. So I'm going to have to go grams of H2O to moles of H2O to moles of hydrochloric acid. Oh, but I want to end with grams of hydrochloric acid, so it's one last step. Grams of hydrochloric acid. So reminder, If it's grams to moles, they have to be the same thing. Moles to grams, they have to be the same thing. But if it's moles to moles, that's when they will be different. Take those units and place them in order in the top of your goalpost. And then we're going to place them diagonally down below. Okay, so I'm starting with 250 grams. Moles over grams or grams over moles, that's periodic table. So it's going to be 1 oxygen and 2 hydrogens. I add that all together, I get 18.015. And notice where I put that, that goes with grams in 1 mole. Now if it's moles over moles, that's going to be our balanced equation. And so hydrochloric acid and water, so let's see what those are. 3 moles of HCl for 3 moles of H2O. If you want, you could reduce it down to 1:1, but you don't have to. And then it's grams over moles, but it's hydrochloric acid. Oh, we already ran that number. Remember, it was 1 hydrogen and 2 chlorines, or 1 chlorine. We did that up here. So that's 36.458 grams per mole. Grams of water cancels, moles of water cancels, moles of hydrochloric acid cancels. And I'll plug it in my goalpost. So I have 250 times by 1 times by 3 times by the 36.458 close parentheses divided by open parentheses 18.015 times by 3 times by 1 close parentheses. And we got 505.939 grams of HCl. Okay, watch the video again if you need to, but that is the process that you're going to take on each of these questions.